outstanding balance calculations. So outstanding balance is when a person goes to the bank and gets a loan, and they agree with the bank that they will pay in a certain amount of time, let's say 10 years. But because something has happened along the way, the person decides, no, okay, fine, I don't want to pay back after 10 years, and I've already paid up until now, I want to finish off my payment after 3 years. So what now the bank needs to do is to then go back, because you can't keep paying installments, you are going to stop paying, you need to pay a lump sum. So the bank has to calculate your lump sum, and that is called the outstanding balance. This lump sum will help balance off your account. So in this case, let us look at the scenario we have. Jack wants to buy a BMW costing 350,000 rand. The bank requires him to pay 10% deposit first. The bank charges 6.5% per annum compounded monthly and agrees for Jack to pay back all the money in 6 years. So now, obviously, as a reminder, we need to remember that we need to do certain calculations like recalculation of the loan. Remember, the recalculation of the loan will give us the P value that we use in our calculation. This is a question on a loan, so obviously we want the present value formula to work. So we need to recalculate the loan to get P. So the first thing is we recalculate the loan to get our loan recalculated, which is at our P. So now if we are going to recalculate our loan, we need to remove 10% from the actual loan. So we need to say P, the recalculated loan, is 350,000 rand. Subtract 10%, which is the deposit. You see there's a deposit here. So 10% of 350,000. 10% of 350,000 is 10 over 100 times 350,000. Or you can just simply start by finding 10%. After you find the 10%, you can then subtract it from the equation. This will give us 315,000. Now, once that has happened, remember, this is the loan that Jack is actually getting from the bank. Now we can use this value to calculate our loan, to calculate our installment. So Jack, the bank is charging 6.5% per annum. Now 6.5 we'll need to calculate the interest will be written as 6.5 is 6.5 divided by 100. I'm just going to press 6.5 there. 6.5 divided by 100 equal to, which is, oh sorry, I don't think I divided by 100 there, so divided by 100, which is going to give us that, but let's change it to decimal, which is going to be 0.065. But because it's compounded monthly, we have to divide it by 12. Monthly means there are 12 months. Now, and another thing that we will need to use, obviously, is the number of the period. 6 years here cannot be used as years. It must be changed to months. And 6 times 12 will then give us our N. Our N will be equal to 72, which is 6 times 12. Now, the next thing we need, obviously, now is the formula. We need to use the formula. So, if we are going to use the formula, you're going to go to your formula sheet, and I am just bringing out mine. I want to show you the formula I'm going to use. So, obviously, in finance, there are going to be two formulas. And the one that I want, let me just try and put this formula somewhere. Let me put them here. So you can see these are the two formulas that are given for calculations, and we want to use the one with the P. So you don't have to remember this formula. As you can see, I don't remember it, and I'm not even trying to remember it, but what I do is I always check before I use the formula. So I know that that's my formula, and I'm going to write it on the next page. So I'm just going to create a new page, and I'm also going to just drag this to the new page like that. So now if I go to the new page, there is my formula, and I want to use this formula. Let me just remove this one. Yes. So because I know I am supposed to use this formula to do my calculations, I cannot use this one. We'll talk about this one later. It's a future value formula, but we want to use the present value formula. So now let's do the calculations. So in our formula, which is P is equal to X, we know what our P is. Our P is the loan, the 315,000, not the 350. Remember, we recalculated the loan. And then we can put our X there. Then we put our bracket, it's a square bracket. Then we put 1, subtract bracket 1 plus 0,065 over 12, close bracket, to the power of negative 72. Remember, our n is negative 72. And then this is divided by 0,065 divided by 12. Now, obviously, now we need to punch our calculator because we need to break it up so that we can work it out. So what I often do is I normally break up I normally work it out in pieces so that I don't make mistakes. So here, this is what's going to happen. I'm going to work out the top part which is in bracket. So obviously I need to be very careful. It starts with the bracket, then 1, then subtract, then bracket again, then 1, then add, then again we've got 0,065 over 12, then again we go sideways, then it's close bracket, exponent, then we put our negative 72 like that, then we go sideways, then we close the bracket, and then we can always just check to see whether we did everything correctly, and I can see that I did everything correctly. Then I press my calculator. So now I know that in here I've got X bracket 0,32230 0,3222. How many twos? They have 3. 30811. 30811. Close bracket, and on this side we've got 315,000. The bottom part again I can also divide just to make sure, and this is going to be I'm going to simplify it. 0,065 divided by 12. It's going to give me so the bottom part here is going to give me, I just need to move my equations forward so that I don't have problems. Let me just try to move everything up, right, so that I can fit in there. Yeah. So I just need to press my calculator, and what did I get when I punch that one? It's gonna give me that ugly thing. So I think I'll leave it as it is. So I'll leave it as that. So it's gonna be, I know it will work. So there's no need to be 0,06512 like that. Now what you then do is you work out the top, the left hand side. So it's gonna be on top there we've got 0,3222 30,811, and then you're going to divide that by that fraction 0,065 over 12, like that. Then you get 59. So it's going to be x in bracket 59, 48765, 48765. Try not to round it off, because you will then create an error of truncating. Then this will be 315,000. So now we have got this one. Let me just take it to the other page. There you go. So this is where we are, and now we want to work out our x. So obviously, to work out our x, now I'm just going to change my color there. X is going to be equal to 315,000 divided by 59. There's a comma there, comma 488,765. So this is what we're going to do. There you go. 315,123 divided by 59.488765. Then you're going to get your answer, which is 5295, 12. 5295, 12. This is going to be your installment X. So that's how we calculate the installment that Jack has to pay, and this is how much he's going to pay on a monthly basis. So now let's go back to our story so that we can understand what is going on. So here they say they are now telling us that if Jack wins Lotto, which means now he has got a lot of money, and decided to pay back all he is owing after 3 years. I think there's a mistake. And wins Lotto and decided to pay back all he is owing after 3 years. How much will he need to? So there's supposed to be decided there to pay back all he is owing after 3 years. How much will he need to pay back the bank? So now Jack has won the Lotto and he has got a lot of money, but remember, he had been paying the loan for the past 3 years, and now he goes to the bank and he wants to pay back the bank what he owes the bank. So what does the bank do? The bank will tell him, okay, fine, let us calculate the money that you owe us after 3 years, and then let us calculate the money that you gave us in the past 3 years. So the bank will take its original loan. It will take its original loan, which is 315,000, and it will give it interest for 3 years, which is 36 months. In the meantime, it will also then say to you, because you have been paying us, so when you are looking at this one, you now know that the bank requires this you should have paid the bank this much after 3 years, which is 36 months. So let's find out how much Jack should have paid the bank in 3 years. So again, we just punch the values in our calculator. It's 315,000 bracket 1 plus, again press this one, 0,0065 over 12, because remember it's compounded monthly, and close the bracket there, exponent 36, like that. You get that amount. So in other words, Jack should have had, that's 382621, 382621, comma 5625, 5625. This is how much the bank should get from Jack in total. This is the money that the bank will want to have after 3 years from Jack. Otherwise, this includes so when Jack is paying back, before Jack pays back, they must consider how much Jack has paid the bank already. Remember, he was making installments all this time for 3 years. So let's calculate how much money he has already paid back the bank. Remember his monthly installment, which was this one. He was paying this for 3 whole years. Now, each installment that he was making, obviously was giving him interest. So in order for us to cater for that, we need to use the future value formula. So if you remember correctly, of the formulas that we had 2 formulas there. Let me just bring this one there. Of the 2 formulas that we had, now we are using this formula, the F formula, because the F formula is the one that calculates how much he deposited and its interest. This is called the future value. So you take all his installments and you cater for the interest that the installments were getting from the bank, and you add them all up, you will get that amount in the form of the future value. So if we're going to substitute, remember our installment is 5295,12, and the rest we just substitute bracket 1 plus our interest is still the same, 65 over 12. Now this is to the power of 36 minus 1, then divided by 0,065 divided by 12. Now what I'm going to do is I am going to punch this the whole formula into my calculator, but this requires you to be a bit skilled. If you are not sure, let me just punch the top part so that I can help those who are always not sure. So this is going to be 5295.12, then open bracket and another open bracket again, and we have got 1 plus, again we put 0,065 over 12 like that, and you need to go back there, up, sorry, it's in a rush to go back up there, and to the power of 36, and then bring it down, subtract 1, then close bracket, and then well, I had already punched that fraction, so I'm just going to divide it by the fraction 0.065 over 12, then close bracket. You must use bracket there, then you press equal to. this is the amount that Jack has paid. It's 272810.8864. Now, as you can see, the money that Jack has paid, which is that, and the money that the bank expects him to pay, they are not the same. That means there is a difference. The difference between the two sides is then called the outstanding balance. So if you put a plus sign there, if you put a plus sign, you put outstanding balance there. So if I want to calculate the outstanding balance is equal to 382621,5625 subtract 27. There's a subtraction there. 2810,8861. So this will give us our outstanding balance. So when we subtract those two on our calculator, we should then get our outstanding balance. I'm just going to try and recalculate it so that some people can see it. I just need it to be a bit bigger. So let's try and see what it was. So there you go. It's our outstanding balance is equal to 382621,5625 subtract 272,810,88 like that, 61. So when we subtract that, I'm just going to press my calculator. 382621.56. It's actually 5625. So 5625, and that will give me 1. I just continued with my calculator, so it looks negative, but it's not negative. 09810.68. That's the outstanding balance. In other words, when Jack goes after 3 years and he says, look, I need to pay off my loan, the bank will say, no problem. All the money you have paid us is going to give us 272,810, and we as a bank require you to have paid 382,621 after 3 years. So you have not paid that much, so we need to subtract and find the difference, and the outstanding balance will be the difference. So that's how we calculate outstanding balance.